Hello, in this video I will demonstrate how the T-Cluster2 algorithm works on the workflow W. Let me show you the workflow W. So as shown here, this workflow has a total of 12 tasks. So we are going to apply the T-Cluster2 algorithm on this workflow. So let's see how this algorithm works line by line. On line 6, we compute all the entry tasks. So in this workflow, we have only one entry task, which is T1. And as you can see in line 6, all entry tasks of W are stored in the variable en. And hence, because there is only one task, en will be equal to T1, line 6. And then let's look at line 8. Line 8 loops through all the tasks in the entry task and then add those tasks to the queue. So in this case there is only one entry task T1, and hence line 8 will produce the queue is equal to T1. There will be only one task in the queue. And in line 10 we set the value of VMID is equal to 1. And line 11 we compute the size of the queue. So in this case the queue has only one element, so line 11 GS is equal to 1. So that's the size of the queue. And then let's look at line 12. The line 12 is going to loop through all the the total number of times, which is 1 in this case. So it's gonna loop only once. And then you can see line 13 we dequeue the element, so P is equal to T1. And then in line 14 we get all the consumers of P. So how many consumers are there for T1? There are two consumers, T2 and T3. So those are added to the queue on line 15. In line 16 we add the task to our map. So in this case D of P is equal to VMID. So what is P is T1, right? P is T1, so hence you will add T1 and then add VMID, which is 1, and we increment the VMID here locally inside the inner loop. Okay, and after that now we will go back again to line 9. So because our queue now has two elements, new elements, it is not empty, so it's going to go inside the outer while loop. In line 10 we reset the variable VMID to be 1 so that we can start over the assignment again, starting from 1. And then GS is nothing but the size of the queue. So as you know, there is the size of the queue is 2, and hence we will loop it twice in line 12. In line 13 we would dequeue the element, the first element here, which is T2. So then we assign it to P. And for T2, what are the consumers? So if you look at T2, it has two consumers, T4 and T5, right? So those will be added to the queue. Okay, then in line 16 the new element T2 would be added to the map. So it's T2 comma 1, and then we increment VMID by 1. So VMID is equal to 2 now. And then it will, because the inner while loop twice for the value of GS, which is equal to 2. So the second time we would get dequeue the first element from the queue now, which is T3. And then for T3 again, we would add its consumers to the queue. So T3's consumers are nothing but T6 and T7. So those are added to the queue. And then T3 we add to the map. So this time, because the VMID the last time was 2, so we use T3 comma 2, and then VMID would be incremented by 1. But the thing to note here is that VMID is a reset in the outer while loop. Okay, so that's why we always maintain the sequence of number starting from 1. Okay, now let's go to line 9 again, and this time the queue has 4 elements: T4, T5, 6 and 7. Again, line 10, as you can see, we reset the VMID to 1, and then GS is nothing but the size of the queue on line 11, which is 4. So we are going to loop 4 times the inner while loop. So line 13, the first time we dequeue the first element, which is T4, and then add the consumer of T4, which is nothing but T8, which is T8 right here. Okay. Then line 16, we would add T4 to the map with the VMID as 1. And then we increment VMID by 1, so VMID will be equal to 2. Next element that we dequeue would be T5. We will dequeue D5, then assign it to P. Now we will be left over with T6, T7 and T8, because the child of the consumer of T5 is T8, so which is already added there. Then in line 16, now we would add a new element, new pair to the map, which is T5, 2, because VMID was 2 the last iteration. Now we incremented it by 3, incremented by 1 to become 3. P equal to T6 now. And then T6 will be added here with VMID as 3. So we increment VMID to be 4 now, and then in the last iteration we would dequeue T7 and add it to the map with VMID as 4. Then we increment VMID again. So as you can see, there is only 4 times that we loop in the inner while loop. And then the control again goes back to line 9, where Q is now equal to T8. It's only one element. And because GS is equal to 1, line 12 will loop only once. So you would have the first element dequeued there, P is equal to T8. And then the consumers of T8 there are 4 consumers: T9, 10, 11 and 12. So those are added to the queue. In line 16, we add T8 to the map with VMID as 1. Because the inner while loop only once, so the VMID will be incremented here in line 17, but then it would be reset the next iteration. So immediately after this, it will again go back to line 9. So this time you would have 4 elements in the queue. So GS is equal to 4, and hence line 12 will loop 4 times. In line 13, you see P is equal to T9, which is the first element dequeued. We dequeue the first element, which leaves the queue with the T10, 11 and 12. Because there's no consumer for T9, no new element added to the queue. In line 16, we add T9 to the map with a VMID as 1. And then we increment VMID to be 2. And then the second time, in the second iteration, we dequeue T10 from the queue, and we assign it to P. And Q now will be T11 and T12. Again, T10 doesn't have any consumer, so the queue has no new element added to it. In line 16, we add T10 to the map with the VMID as 2. This VMID was equal to 2 in the previous iteration. And then we increment VMID by 1 and become 3. And we dequeue T11 from the queue and assign it to P, which leaves the queue to be just one element, T12. And T11 now would be added to the map with the VMID S3. And finally, for T12, when you dequeue it from the queue becomes empty because there's no more element in the queue. So T12, we assign the VMID as 4 and then add it to the map. We increment VMID to 5. And then it would again go back to line 9, but then because queue is empty, it will break out of it. Break out of it, right? Okay. So that's in short the demonstration of Cluster2 algorithm, and then I have already shown the output of comparing both Cluster1 and Cluster2. As you can see, Cluster1 uses up 7 machines, whereas Cluster2 uses a maximum of only 4 machines. Thanks for watching this video.